talk about the various aspects of this. And I think it's going to be very exciting. And so the way the format is going to be that everybody is going to come and speak for about 7 minutes. And at the end of that, we will actually have we'll have a panel discussion where we'll talk about the various things that, various issues and challenges with Gen AI. So without further ado, I will basically bring up our first speaker. Our first speaker today is actually going to be Dr. Pandu Nayak, who's Global Vice President of Google Search. And he is responsible for actually search quality. And before joining Google, he was chief architect and CTO in a legal discovery company, Stratify. And previously, he has worked at NASA. He has a BTech from IIT Bombay and a PhD from Stanford University. Welcome, Dr. Nayak.
Thank you very much. And it's great to be here with all of you in person, particularly at this rather exciting juncture in the development of AI. Now, for decades now, Google Search has been using AI to improve the user experience for our users. You know, going all the way back to the simple business of spell correction, that was a form of AI that we used, and it's been used consistently throughout the years. Today, though, AI is fundamentally changing the way we think about search. And not just we, but the way our users in India and all over the world are thinking about what it means to search, right? If I asked you for a moment to close your eyes and think about what does it mean to search, you probably think there's a little search box and you type into it. But in fact, what's happening today with a lot of people, particularly in India where there's a lot of young people and there's lots of mobile phones, there's every chance that what they're doing is speaking their question aloud, or maybe they're searching with an image, or with a photo, right? And this business of having search be really something where you can ask your question verbally, or where you can use Google Lens to do your searches. All of this is enabled with AI, right? And it's really proving to be transformative, particularly, as I said, in places like India, where a huge fraction of queries are by voice. Google Lenses already gets about 12 billion queries, image queries a month. So there's just been this transformation that has been enabled by AI. Now, more recently, there's been just a lot of excitement about generative AI. And large language models is the technological underpinnings of this generative AI explosion that we are seeing today. And frankly, sometimes the things that it does can seem pretty magical. But of course, there's no magic here. These LLMs, large language models, are effectively just very sophisticated prediction engines, right? That's what they do. Now, I'm sorry. When I say prediction engine, what they're really doing is, given some context, they're able to predict what comes next. And so the context can be the beginning part of a sentence and they can complete the sentence. Or maybe the context is a question and they can produce an answer. Or maybe the context is a whole conversation that you're having, so multiple back and forths, and then it can continue the conversation. And the reason that these conversational agents can do this kind of thing, why LLMs can do this, is because LLMs are trained on just a huge amount of data, right? Just to give you a sense of scale, Bard is Google's conversational agent, and the LLM that underpins Bard is trained on over 1 trillion words, right? Think about that. That's like being trained, or that's like reading millions of books out there. So it's pretty remarkable, and what that allows it to do is this kind of prediction that feels almost magical. And the remarkable thing is these things are multimodal today. So not only can they predict words, They can predict images. They can create images for you. They can, of course, create code for you. So there's all kinds of remarkable things that this technology does, which is pretty amazing. Now, Google's motto for creating AI-powered products is to be bold and responsible, right? Now, given the remarkable technology that is LLMs today, the bold part is pretty clear. There's something pretty amazing going on here, and we're going to build all these amazing products with it. But being bold isn't enough, right? You need to be responsible from the start. And the reason for that is that this LLM technology, wonderful though it is, also has some well-documented challenges around things like safety, things like factuality, and so forth. And so you need to be able to address these things head-on from the ground up. So let's talk about Bard. Bard is the conversational agent that we've developed. And the development of Bard is guided by these AI principles that Google put out back in 2018, I think, 5 years ago. And one of the implications of that is we take safety in Bard very, very seriously. And the way we do this is because we've been developing Google Search. This is what I've been working on for almost 20 years now. We've been developing Google Search for all these years, and we've taken safety very seriously within Google Search. And so we have a lot of experience on what it means to develop safe systems like this. And we've brought all those learnings into Bard to try and enhance the safety of the kinds of responses that it makes. Factuality is also something that is very important for Google. It's really been a core value for Google Search to surface high-quality results and so forth. And it's no different, different with Bard. Given the technology, we've applied many of the sort of state-of-the-art techniques to enhance the factuality of Bard. Things like reinforcement learning with human feedback, RLHF, that had been pioneered originally at DeepMind there. So RLHF is one of the techniques that we use to improve factuality. We use things like retrieval augmented generation to make sure that we corroborate information effectively. And so all of these things are things that we work on to continue to make Bard as effective as possible. We also taught Bard to actually corroborate the information that it produces by going to Google Search to look for corroborating evidence for the assertions it makes. Right? And so there's a Google it button that you can find, and when you click on it, it'll annotate its responses with corroborating evidence to say, yes, I found something that supported it, or maybe I found something that didn't support it, and that gives you context on how to interpret the responses that were made. Now, earlier this year, we also brought generative experiences to Google Search, right? This is something that we call the search generative experiences. And just like everything else we do in search, search generative experiences, or SGE for short, its goal is to help users get to the information they need as quickly as possible. Following the original launch of SGE in the US, when was it? I think it may have been back in March, or no, in May or something like that. More recently, we brought it to India as the second country to launch it, and it's had a really good reception. It's currently launched not as part of the default experience, but as an opt-in experience that you can log into, because we want to make sure that it works well for search. SGE is powered by several different LLMs, including Palm 2, which until recently was one of our largest language models. More recently, over the last week or two, we also launched Gemini, right? And we've been experimenting with Gemini for SGE. One of the cool things about Gemini is it's been built from ground up to be multimodal. The LLMs that we use for SGE have been purposefully fine-tuned for search-specific tasks, things like surfacing corroborating evidence in various ways from high-quality sources. And we hold SGE to a high standard, particularly for the so-called your money or your life areas, health, finance, civic information, and so forth. Let me talk about one other challenge with LLMs, and that has to do with bias, all right? And this is something that has been sort of top of mind for a lot of people, particularly in areas like health and finance and so forth. I think part of the problem with unfair bias stems from the training data that you use, right? LLMs have a possibility of enhancing these kinds of biases. And so getting the training data right is crucial. We're partly mitigating that by using, again, our the work in Safe Search to make sure that we don't train on unsafe content. And BART goes a step further than that in debatable areas by essentially, when there's consensus, it surfaces the consensus, but when there is no consensus, it surfaces multiple perspectives. And one sort of last point on this, when we think about what governments can do in this area and policymakers, I think it's important for policymakers to commit to supporting trusted cross-border data flows, so that the training data that can be used is representative of a diverse demographic and a diverse set of people, so that you can sort of address bias in this way. And so with that, let me conclude. I know I've gone a little over here. Just want to say that there's a lot we can accomplish, but we need to do it all together. So thank you very much.
The next up, we have Microsoft, and Mary is representing Microsoft, and she is Vice President of Strategic AI Initiatives at Microsoft, and she's been responsible for much. She's also a frequent speaker. Oh, sorry. So, and Mary is often a speaker on CSR initiatives at Microsoft, as well as technology policy in its relationship to AI. And she previously headed Microsoft Global Philanthropies, and she's been an active member of many nonprofits in the US, among them the YWCA of Seattle, the Seattle Art Museum, and the National 4-H Council. And she was actually the very first female attorney to be at Microsoft. So welcome, Mary. And
the slides are up? Do you have slides up? Okay. Good morning, everyone. It's wonderful to see all of you today. I'm going to talk just a little bit about generative AI. And first, I want to just do a little bit of grounding, that this technology is here. It's not going anywhere. And in fact, the rate of adoption for ChatGPT is the fastest we have seen for virtually any technology in the past. You can see that it just took 3 months for ChatGPT to acquire 100 million users, compared to some of the other technologies that you see on the slide. The other thing we know is that technology drives GDP growth, and that the pace of change of that growth is also accelerating. So you can see here over time growth in GDP with the adoption of technology starting way back with the printing press, the steam engine, and then PCs and the cloud. And you can see that hockey stick, or maybe cricket stick, I should say here, going up faster and faster and faster. And so it's really important to acknowledge the role of technology in driving GDP growth in economies like India and others around the world. We know that generative AI has just tremendous potential. And whether that is talking about sort of the physical infrastructure, whether it's relating to telling farmers when to sow their seeds based on what the weather conditions will be, what the soil moisture is, or whether it's a small business holder for an e-commerce and payment system that's really important, or whether it's something that really relates to getting government benefits. We know that generative AI can really speed up the efficiency of these kinds of needed, much needed technologies. We also know that in addition to just sort of the digital goods, the economy, that there are many other ways in which generative AI can aid social good. In this example, we see a product called Seeing AI from Microsoft, developed by a Microsoft engineer, which enables those with low vision or no vision to be able to translate the world around them using translations for text, objects, those kinds of things. We see tremendous potential in fields like medical research, cancer research in particular, and other fields as well in the healthcare realm. So lots of support in both the economic parts, but also support in more of the social good part, which is so important to all of the countries. Generative AI can also be used in an area that we're just really starting to learn. I shouldn't say we're just starting to learn more, but it's become much more in the public consciousness, and that's sustainability. And the ability to use artificial intelligence to help manage both hazardous conditions, but also to mitigate in terms of energy efficiencies, methane emissions, carbon dioxide emissions, water replenishment is absolutely going to be really changing the world going forward. But at the same time, we know, as my boss, Brad Smith, who's the president of Microsoft and co-chairman, says, technology can be used as both a tool and a weapon. And we have to be very clear-eyed about that. Clear-eyed but optimistic, but we know that there are some things that we should not ask computers to do, that there are places where we know that humans need to be involved. And so as we think about the policy ramifications, we have a 5-point sort of framework that we think about. First of all, we need to build on those standards that are already here. Secondly, for those critical infrastructure pieces, it's absolutely important to have a human making the final decision. We need to develop a broader framework, which is the purpose of the GPAI conference today, to think about building consensus and developing regulatory frameworks. We need to be transparent in what we're doing, and we need to ensure that there is public-private partnership with both nonprofits and academic institutions to ensure the full benefit of this technology. As we think about that regulatory architecture at the applications layer, at that BARD layer and at the Bing layer, I have to say Bing, it's important to apply the existing laws and regulations at that app layer. At the layer of the LLMs, it is also important to ensure that these LLMs are developed in a way that tries to remove unconscious bias and discrimination and tries to ensure that there is safety and security in the model itself. And then finally, at that lower level, the data center itself, it's important to ensure the safety of the data centers, whether that be related to the physical structure or whether that be related to cybersecurity and those kinds of things too. So we understand that there will be lots of discussion about the layers of technology, and it's important to apply the regulatory framework to the layers themselves and to adapt the regulation to the particular stack of technology as we go forward. And the GPAI conference, I know, will get us a lot closer in thinking about not only the regulatory framework, but adopting it in the particular stacks. So just as an example to think about how all of this might work, I want to give you an example of our air travel system. Really, when I think about it, when I came here from Seattle, Washington, I put myself in this huge metal tube. I closed the door with 200 people or 500 people that I didn't know, and I was absolutely comfortable knowing that this tube would take off, that it would traverse thousands of miles, and that it would land safely. That does not come about by accident. That is a lot of collaboration between industry, between government, and across governments to ensure that we create those kinds of safety standards on a global basis to ensure that that plane takes off, lands securely, and that when I am on the plane, I am safe as well. And so we should think about this technology in the same way. How can we create that international collaboration, working industry with government sector, working with civil society to ensure not only physical safety and trustworthiness, but also ethical uses of the technology as well, and ensuring at the bottom that it is human-centric, that the technology aids human intelligence, empathy, and compassion. We know that we do this across a multi-stakeholder approach. Here are just a few examples of organizations that are working together to develop the kinds of standards that we know on an international basis will enable us not only to deploy the technology efficiently, but also employ the technology for good. Thank you very much.
Thank you, Mary. Thank you, Mary, and thanks for being on time.
I got you to the second.
That was perfect. Our next person is actually going to be joining us virtually. Mr. Jason Oxman is President and Chief Executive Officer of the Information Technology Industry Council, the global trade association for the tech sector, representing the world's most innovative companies. And he brings more than 25 years of experience as a globally recognized leader in technology policy and serves as a leading advocate for technology during a consequential time for the industry. So without further ado, we will play the message from Jason Oxman.
My name is Jason Oxman, and I'm the President and CEO of the Information Technology Industry Council, also known as ITI. It's a privilege to join this esteemed panel of technology policy experts at today's 2023 Global Partnership on Artificial Intelligence Summit. Thank you to GPAI and the Government of India for organizing today's important discussion. ITI is the world's premier advocacy, policy, and thought leader for the technology sector. We represent 80 of the most dynamic and innovative companies on the planet. Our members stand at the forefront in developing and deploying global consumer-facing, business-to-business, and government-focused AI solutions. In fact, AI is a key priority area for all ITI member companies as they leverage this technology to evolve their businesses and to benefit consumers. We are committed to the responsible development and deployment of AI. Well before AI captivated the world's attention and became a dominant topic in policy conversations, ITI was leading the international discussion on the technology. Over the years, we've met with policymakers and stakeholders on how to promote and govern the responsible and transparent development and use of AI. ITI's representative in Delhi has engaged with the Indian government, with technology sector stakeholders, and with member companies to advance policies that support AI innovation throughout India. I've also had the pleasure of engaging directly with the Indian government on these key issue areas during my most recent trip to India this year. Today's conversation is another important opportunity to continue a robust public-private dialogue when it comes to advancing responsible AI technology. Now, it doesn't take an expert to recognize the vast opportunities presented by AI and its adoption into our daily lives. It's also not difficult to see how AI is poised to transform the economy and industries from healthcare to the environment to financial services and beyond. While I was in India, I learned about AI's important role in agriculture, where it is helping rural India to prosper. I also learned how large language model development in regional languages is making the benefits of AI accessible to those whose primary language is not English. AI is a great tool, especially in a diverse country with a huge number of dialects. These are just a couple of examples of the real-life benefits of AI in India, and there are many more to explore in today's conversation. Today's panel will examine generative AI and how to approach this transformative technology in a way that mitigates risk and safeguards user privacy and security while reaping its immense benefits. This panel is timely. It follows two recent policy developments on AI. Last week, the European Union agreed to a final text on its AI Act, a major milestone for AI governance in Europe and globally. As negotiators work out the details of the measure, the technology industry is watching closely to ensure that the final legal text delivers a clear, proportionate, and risk-based framework. Also, in October, US President Joe Biden signed an executive order on safe, secure, and trustworthy AI. This broad and sweeping effort aims to support innovation in AI while also tasking agencies across the US government to evaluate and address key risks. The executive order underscores how much work the US government, alongside global partners in industry, must do to advance a common vision of safe and secure AI. Across the globe, ITI has urged policymakers to focus on fostering public trust in AI by taking a risk-based approach to regulation and emphasizing the key role of transparency in these conversations. Transparency and public trust are equally important when discussing how to address risks stemming from the use of generative AI, while also ensuring that citizens and organizations around the world can reap its benefits. India is a key global partner with an important role to play in AI policymaking. We welcome the Ministry of Electronics and Information Technology's recent establishment of expert groups and centers of excellence to assess how to advance AI for all of India. We also encourage Indian lawmakers to harness the G7 International Guiding Principles and Code of Conduct on Advanced AI Systems as they consider how best to approach governance of generative AI systems. The G7 Principles and Code of Conduct are a good first step toward a risk-based approach to governance of advanced AI systems, including generative AI, and importantly, they offer a global approach that can help ensure interoperability of practices on an international scale. As India's efforts on AI policy move forward, we encourage policymakers to continue to partner with and seek industry's input. ITI looks forward to working with the Government of India and stakeholders in India and around the globe to ensure AI can be leveraged for the benefit of all. I look forward very much to today's discussion, and I thank you for the opportunity to join you.
Yeah, thank you, Jason, for that message. And we move on to our next speaker, who is Arun Subramaniam, who is Vice President of Cloud and AI Strategy and Execution at Intel. Arun has a PhD in aerospace engineering and has actually been had led the development of the digital twin platform at GE. And prior to joining Intel, he was at AWS, where he led the extreme scale computing team, which spanned things like quantum computing, machine learning, autonomous vehicles, etc. So therefore, without further ado, Arun.
Good morning, everyone. Thank you so much for the opportunity to be here. And it's really wonderful to be talking to such an august group here. So I thought today I'll just introduce the concept of democratizing Gen AI responsibly. And what do those words actually mean? And what can we be having a dialogue around? You heard some great conversations in the morning. I hope that this will spur a few more conversations as we get into the Q&A as well. Right? I wanted to show you two different studies. The one on the left of the screen is really something that's a consensus from the last decade of data transformation and traditional AI and ML being applied across the world. And these numbers are a consensus of numbers across different studies from IDC or McKinsey or any number of different groups that put numbers out. The consensus is about 10% of the projects that had an AI or ML moniker over the last decade actually reached the outcome they promised in the beginning of the project. Right? Said a different way, 90% of them failed to meet the targets, right? And that's after about a decade of adoption. The numbers on the right are brand new. So it's a study that just concluded in September. Roughly around 600 different Fortune 1000 companies participated in them, and it's still ongoing. And about 60% of the time of the companies at the time, that September just a few months ago, reported that they're doing something with GenAI. 40% said they're not really doing anything. In the last 3 months, that number dropped. So about 90% of the companies are self-reporting that they're doing something with GenAI. What? We're not really sure. So the next level of question was, have you actually scaled something with GenAI? Meaning there's a definition of scaling that at least 2 of your business units should have deployed this technology in production. And production is at least 100 users. Right? So that's a higher bar than just trying something out, small POC. You generally do that in a few small groups. So that's a higher bar. And the number that shocked us was 9% of the companies actually came back, self-reported that they actually meet that criteria. Now the number on the left side is after 10 years or more and billions of dollars sunk into it with enough number of enterprises getting on. The number on the right side, at most a year, less than a year in most cases. They're already starting to scale. So that's really where you're seeing a lot of adoption coming on, saying this is faster than anything we can, that we can actually think about, faster than anything that people can hope. Of course, this is coming on the heels of all the data transformation that people have already familiar with. So the data is there. They need to be able to apply something new. Now we'll see if these numbers hold for the next 6 months or the next 12 months, because this could also plateau out, this could crash. So we'll see how these numbers hold. But for now, the scaling seems to be picking up, right? That's one number. The other question that just got released with the latest study from a variety of different groups, this was done between MIT, Wharton, Boston Consulting Group, and Harvard Business School, where they studied the impact of deploying generative AI technologies into a diverse workforce. So this was a group of about 750 participants across multiple industries, and they spanned 3 different buckets. The first bucket were a group of people who are brand new, so less than 3 or 4 years out of college. That's brand new group. The second group was in between, so between 5 and 10 years of experience. The third group was a control group that was really considered experts in their own fields, longer than 15 years in that particular field, right? And so these numbers are aggregate across all of these 3 groups. And what happened across the board, if you gave them creative tasks to do, things like how would you come up with new ideas, how can you go and figure out what would be possible given an ambiguous situation, overall, the individual productivity went up, not by a small number, but 40%. And that's across an aggregate of all 750 people, right? That's great. And this was also compared to a control group that was not given anything, so they could actually control the experiment. But what also happened was the collective group's creativity went down by about the same number, meaning everybody's ideas started looking more or less the same, right? And it is not like they were given different ability to prompt, different abilities to go look at different kinds of GenAI technologies. It was the same technology that was given to them. And this report is public. You can go read about this as well. But the interesting thing that happened is both experts and novices tended to start looking at the responses in similar ways as long as they build some trust in the system. And the creativity takes a big hit. The flip side of this, of course, is how do companies and enterprises and governments actually differentiate? Now, if everybody looks the same, everybody has access to the same tools, and we end up democratizing all of these capabilities across any number of different vendors, how do you differentiate? Right? That's a big question that's also coming up. So you enable something, you increase productivity, but then everybody looks and says and feels the same thing, right? So that's really where a lot of conversation around, okay, today's public large language models, proprietary large language models, a few of them that you heard about today, are all great. They have fantastic capabilities, but they also are pretty much maxed out on the kind of data that they have access to. We heard that, of course, it's 1 trillion words. It's massive amount of information that more than any one human being can process. But that is what I would call a mile wide and an inch deep, because about 95% of the world's data is still dark. It's inside enterprises, it's inside governments that the model doesn't have access to yet. That's really why we think that the domain-specific models, localized models, would actually get adopted a lot more. This is not a representation of the size of the model. This is just a representation of the adoption rates of the models itself, and then where it could potentially go, and where we're already seeing public-private partnerships coming together to start with a base model and then grow from there, right? So that's the combination we are potentially starting to see grow as well. And I promised to talk about democratizing Gen AI equitably and responsibly, right? So today's large language models evolved because there was a large amount of data sets that were available. There's reasonably large amount of compute that was available, but then they also built out compute specifically for these kinds of models. These kinds of compute environments didn't just exist before. They're pretty much custom built for building these models. So they had a set of outcomes in mind that drove the data set size, and then there was some back and forth between what you can get it. The model sizes and the data set sizes combined kind of dictated what kind of compute needs you needed. And the trifecta between data set size, model set size, and compute requirements enable the outcomes that you're seeing today. The problem is that kind of compute is only available to a very, very small group of people. And the inverse of doing the evolution really is to say, okay, I have access to compute that is very limited. Therefore, let me figure out what data set size I can actually get access to, which will then dictate what kind of model sizes I can actually build, which will then actually get the kind of outcomes you will go after. Right? That's what I would call the non-equitable democratization of this technology, where let's just limit ourselves upfront before going and building a model in terms of what access we think we can get. Really, the equitable approach to doing this is actually going in and doing it responsibly, where it's not sustainable to just keep increasing the model sizes and the compute sizes going up. We really have to think about carefully the outcomes we want to enable. Let the outcomes dictate the size of the data set. And let us work together with the experience of building these large models and improve the technology to make sure that we can actually have these models behave in a way that they can get us the outcomes in a way that is sustainable from a compute perspective, right? So the compute sizes have to shrink. The model sizes can change, the model types can change, the architecture can change itself, but we need to be responsible of thinking about outcomes that don't actually shrink. In fact, the outcomes have to grow with lower resources, so we need to figure out how to do more with less, okay? And the last point I would make really is around benchmarks. They're definitely necessary, but not a sufficient condition. And we're rapidly going towards making Goodhart's law real for this particular use case, because the minute you turn a measure into a target that people need to achieve, then that becomes useless as a measure itself to actually start comparing. And we're rapidly acknowledging that, because you can go look at any number of leaderboards around the world. A model says they're fantastic in a particular leaderboard. The next day another model comes out, they are better in a different leaderboard. And then you keep going at this game. It's needed because somebody has to say, what are you comparing against? But we also have to look at that from a responsible standpoint to say, is it useful? I'm maxed out on a particular leaderboard, but can I actually deploy this for my particular use case? Can I do it in a sustainable cost basis? Can I actually deploy it in the geographies that I need to be deploying it? Those are also axes of comparisons that we need to be having a conversation around. And I just want to end on the note of caution that benchmarks are fantastic, but they're not the only ones we can rely on. Thank you so much.
Thank you, Arun. And our next speaker is Professor Vikram Madhve, the Donald B. Gillies Professor of Computer Science for University of Illinois. Adve's research lies in developing and using compiler techniques to improve the performance, programmability, and energy efficiency of computer systems. He, along with his student, was responsible for the LLVM compiler architecture, which is used in a number of, in Apple devices and NVIDIA GPUs, lots of different places today. And he is also the co-founder of the Center for Digital Agriculture at the University of Illinois, and leads AI Farms, a national artificial intelligence institute that's been created to tackle the challenges faced in world agriculture. Thank you, Vikram.
Thank you very much, Vivek. And thank you very much for the opportunity to come and speak here. I am really encouraged to see that both GPAI but also the Indian government is really taking AI very, very seriously, both the challenges and the opportunities. I'm going to focus a little bit here on AI opportunities in agriculture, although I do think that ag as a domain is sort of a microcosm of quite a few other domains in the world that have advanced technical and challenges, but also enormous social benefits. One interesting observation about ag is that modern agriculture really is, I would say, quite far behind the curve in the adoption of AI and some other advanced technologies. It has seen relatively low penetration of technology and AI, broadly speaking, and that is even true in the most developed countries today. But in the global south, for example, where farming is typically quite small scale and relatively low tech, it's even further behind. But at the same time, I think that generative AI technologies have really strong potential in agriculture, and there are a few reasons for this, mainly because of some essential features of modern agriculture. One of the most important is that for successful farming, for productivity, for sustainability, advisory services are absolutely crucial to enable the adoption of better practices, both advanced technologies, but also fundamentally better management practices. But at the same time, many low-income and smallholder farmers have very limited access to advisory services. In the West, for example, land-grant universities have very sophisticated extension units that provide advice to farmers. These were created in the time of the Civil War by Abraham Lincoln and have been developing ever since. So they provide tremendous benefits to the farming community, but it's not true in many other parts of the world. But I think that's one potential opportunity for generative AI, where you can provide automated advisory services, but I don't think that's actually the most effective way to deploy these kinds of services in practice. I think that there are professional crop advisors, agronomists, extension specialists, and others who help farmers make decisions in farming, in production farming. And they have to have an understanding of the literature. They have to be able to provide expert guidance. And I think that is, in fact, a much more effective way to deploy some of these generative AI tools and services. It's also true for scientific researchers, by the way, who have to keep up with the vast literature. Ag tech industry professionals also have to be able to stay on top of extensive technical knowledge and can benefit from these kinds of tools. Another really important dimension is that farming and farm management is an extensively quantitative domain where you have to make data-driven decisions with quantitative predictions about the outcomes of different farm management practices. And this is crucial to productivity and sustainability. And so all of these features, I think, are can benefit from generative AI tools and services. In the AI Institute that I lead, AI Farms, we have a project called Crop Advisor that is intended to be an interactive, data-driven advice and decision support system for farmers. I'm just going to spend a minute on this just to illustrate the kind of capabilities that we think are important in this kind of domain. This is aimed at the full spectrum of agriculture professionals, from farmers, crop advisors, industry advisors, as well as government officials and many others. And it has to be extremely multimodal, because ag fundamentally is very much driven by all kinds of different data, including images, video, as well as text and speech. We aim to give responses with both text and images with multimodal analysis. One of the most important aspects of agriculture is that it's extremely local. The decisions, the nature, the optimization choices that farmers make are highly dependent on the soil conditions, the weather conditions, the local products, and so on. So the tools have to be very locally driven. They also have to be data-driven because, as I said, it's very competitive. And we aim to make this tool be open source and public domain. And in fact, the right way to think about this is not as a single tool or service, but really as sort of a collection of technologies that can be adopted in bits and pieces and added to both existing products or to create new products and services on top of this. And this is a very quick screen grab from the current version of the tool, which can take an image and a query and actually give you reasonably informative answers about what's going on in the image. I won't try to take you through this today, but if anybody's interested, I'll be happy to talk to you about this offline. So I think one important aspect of generative AI in the context of agriculture, but this very much holds in many other advanced technical domains as well, is that I think what you're seeing in terms of the capability of the technology today is still quite limited. We're only really scratching the surface, and there's a lot of advances, technical advances and policy advances needed to really make it be successful and fulfill its full potential. One of them is that modern computer vision techniques really have very limited semantic understanding. Even though this is one of the most successful aspects of AI and generative AI, it's still very limited in its understanding of the underlying semantics and the domain itself. Second, decision making really is very data driven in many different domains, including agriculture, but the kinds of automatic code generation and API invocations and so on that generative AI tools do today have relatively poor accuracy. And so there's quite a bit of research that's still needed in order to improve the reliability, accuracy, the effectiveness of the code that's generated by these tools. Third, agriculture fundamentally is a deeply technical domain. There's literally thousands of years of research in this area and dramatically deep domain understanding and scientific understanding. It's true in many different domains, of course. But getting the underlying technical understanding of the domain is going to be important to improve the quality of these generative AI tools. And finally, there are very serious policy challenges. I think this is true in almost every domain. One really important point, though, is that the challenges vary and differ quite significantly from one domain to the next. So, for example, there's a lot of concern with things like deep fakes and serious privacy issues and security issues. These are not actually the dominant issues in agriculture. There are other more important issues like the challenges of data ownership and silos, which make it very difficult to actually access all the data that's needed. The infrastructure costs are serious, the language barriers are serious, literacy barriers are serious as well. So that's my last slide. I really believe that we are very, very early in terms of exploring the technology and the potential of the technology for addressing many world goals. I think we're in the first over of the first inning of this test match, and we have a long, long way to go. I think the technology holds tremendous promise, including in very low resource domains like agriculture. There are significantly fewer risks in this domain, which kind of hopefully will make it easier to deploy the technology. But at the same time, there's a lot of advances needed to really fulfill the potential, as I said. Thank you very much.
Thanks, Vikram. Thanks, Vikram. We will now go to Dr. Janine Berg from the International Labour Organization, an expert at the GPAI Working Group on the Future of Work. She's a senior economist and head of the Effective Labour Institutions Unit at the ILO, and she's the author of several books and numerous articles on employment, labor, market institutions, and the digital transformation of work. Thanks, Ginny.
Thank you so much. So I'm going to shift gears a little bit and talk about what are the potential effects of generative AI on the labor market. Since the launch of ChatGPT last year, there's been a lot of articles in the press about a pending jobs apocalypse, and so we wanted to address this question with an analysis. My coworkers and I did a study, and we actually used ChatGPT for our study, which was also very helpful because it gave us a lot of insights into how we could augment people's work at work. So since I don't have much time, I'm not going to get into all of the methodology, but I just want to explain a little bit so you can understand what we did. So every day we go to work and we do a lot of different tasks in our job. So all jobs have tasks within them. Jobs are classified according to the International Standard of Classification of Occupations. There's 436 occupations in the ISCO, it's called ISCO 08. What we did was we used ChatGPT and also our expert knowledge to look at the tasks and to see which of these tasks could be potentially exposed to generative AI technology. And then we did a clustering of the tasks by these broad occupational categories. So as I mentioned, there's 436 occupations, but they're categorized. There's a 3-digit level, 2-digit level, and then the 1-digit broad category. There's 9 main categories. If you look at the main categories, what we did is with each of the tasks, if it had a score of 0.5 or above, you had a medium exposure to the technology. If you had an exposure of 0.75 or above, it was high exposure. So we did a semantic cluster with the technology, we used it, and this is our results here. So if you can see, clerical support workers, that broad occupational category, which would include secretaries, administrative assistants, call center workers, many people in business process outsourcing, 58% of their tasks have a medium exposure to generative AI technology, and 24% of their tasks have a high exposure. When we look at technicians and associate professionals, service and sales workers, it's all about 25% of their tasks. So they have some exposure, but it doesn't necessarily mean that they don't have a huge exposure. There's still a lot of things that they have to do during their day that would keep them from being automated. You can see that clearly at the category of managers. So 14% of their tasks in total are exposed to generative AI, but of course they're dealing with clients, they're trying to get new clients, they're having a lot of face-to-face interaction, and those types of activities would be what we would call augmented. The other lower tasks, which are basically people doing physical jobs, also very much face-to-face human interaction, have less exposure. So the last presentation on skilled agricultural workers, 8% of their jobs of their tasks could be potentially affected by the technology. So in the next step, what we did was to take these numbers and then apply them to labor force survey data to get a global picture. So this is our main contribution. At the ILO, we have a microdata repository, so all of the national statistical offices send us their data and we have it. There's about 170 countries with labor force survey data, some of it very good, some of it not so good. Enough countries at the 4-digit level that we were able then to do an estimate with countries that had 3-digit or 2-digit level to do this global estimate. So let me talk about the bottom panel first, and then I'll talk about the top panel. So the bottom panel is on automation. So a few caveats. First of all, this is assuming that everybody that's exposed to the technology is going to be using it. And that's likely not going to happen, because we know that in many countries you have poor internet connection, poor broadband connection, you don't have digital skills, and of course there's a lot of delays in incorporating technology. The other speaker talked about how a lot of companies haven't even used this technology, or they just use it very quickly. So many organizations are not going to adopt it. So this is very much an upper threshold, and the point of this analysis isn't to make bets about the big numbers, but rather to indicate the numbers so we can prepare ourselves in terms of policy. So the countries that would be most affected by this would be high-income countries and upper-middle-income countries, and that's really a reflection of the way that their labor force is structured in those economies. So they have a lot more jobs that would be potentially exposed to the technology. If you look at high-income countries, we see 5.1% of employment, and most of this would really affect women. So women is the orange bar, so 3.5 percentage points of the jobs that would be lost would be women's, and that's because women are more likely to be in clerical occupations. In low-income countries, it's 0.4% of employment, just because you have fewer people in those jobs. Then the top number is the augmentation potential. So augmentation potential is people like myself who are able to use the technology and become more productive, but not necessarily be automated. At least I hope not. So if you look at the augmentation numbers, you see that the potential for augmentation is 13% in the world. Low-income countries still have a high potential for augmentation if they were able to adopt the technology, 10.4%, and in high-income countries, 13.4%. Now, this does not account for new jobs that will be created. We know that with every technological transformation, there are new jobs that we can't think about. Today in the United States, 60% of jobs that exist did not exist in 1940. And I always like to give the example of mobile phone repair shops. You see them in every corner, every place in the world. They didn't exist 15 years ago. So there's always new jobs that are being created. And in fact, we know that even within this space of AI, we have millions and millions of people who are training AI systems. And those are examples of new jobs, but not necessarily great jobs. So I don't have time to get into, well, I'll get into a little bit, the policy recommendations. So the main objective of this analysis was really to just get policymakers to start thinking about what this means in the world of work and what could be done so that we don't react, we actually proact. So with respect to automation, we have some kind of broad recommendations. First about, if a big organization adopts the technology, within that organization to prioritize redeployment of their staff rather than job loss. To use social dialogue to discuss with the workers' organizations or with the workers themselves about this. To provide social protection and skills development to those affected, so this could be within the company or this more broadly society. People do need to be trained, people need to be upskilled, but people need to have some sort of income when they're going through that training. If they don't have income, then they don't do the training, and usually then they have scarring effects in their career path. We need to be investing in sectors that are underfunded, that there's a lot of need in the world, such as in the care economy or the green economy. And we need to ensure that these new jobs, such as these data labelers, are actually jobs of good quality. For augmentation, so augmentation can be really positive, but it also can be negative if it's imposed onto the workers without any discussion of the workers. And I think we've all had experiences in the workplace when new technology is introduced to us and there's no feedback from us and it just doesn't work well. And this can affect people's job quality. So it's really important to have this dialogue with workers or workers' organizations about how technology is designed, about how it's deployed, and having this discussion with management about how technology is used. So this is really important, especially since some of this technology can take decision-making away from the employees, which then reduces their job quality. And this, of course, is more easily done when workplaces are unionized, but even if they're not unionized, when there's workers' engagement. So thank you very much.
Thank you, Janine. Our next speaker is Professor Alastair Knott from the Victoria University of Wellington and co-lead of the GPAI Social Media Governance Project. Professor Knott works in the area of cognitive science and artificial intelligence, and he was also a co-founder of the Otago University's Center for AI and Public Policy in 2018. Thank you.
Hi, everyone. Thanks again for inviting me on this panel. It's a very interesting opportunity. So what I'll be talking about is one bit of work that we did in the GPAI project that I co-lead with Dino Piedreski, who's here on the slide. This is a social media governance project overall, I suppose. And so we're thinking about how social media could be overseen and what's going on with AI and social media. But in fact, in this talk, I'm going to talk about a specific proposal that we have in the area of AI-generated content. And it's kind of a typical GPAI project, I would say, in the sense that we're suggesting a particular technical solution to a particular technical problem. And that's kind of what GPAI is all about. It's a group of AI experts. And so see what you think. So here's the central problem. The internet is about to be flooded. Well, not just the internet, actually. The world is about to be flooded with AI-generated content. So this is likely to be a problem, it seems to me. We're going to have a completely new information ecosystem. We have situations that we've never had before in the area of authentication. So until now, we've always known that if you see a photograph or a picture where it was taken by a person or drawn by a person, and if it's text, well, by God, it was written by a person. But we no longer have that certainty. So we have this new question that we've never had before. It's never arisen before. Was this given item of content created by a person or a machine or some mixture? So that's the question that we'd like to address. It's a technical problem, I suppose. We're looking for what is a good technical solution to this, and how can we sort of move towards that so that we can answer this question? So I suppose maybe the first thing we should say is that why is it important to know this? Well, I don't think there's a single reason. You might think that there's, we have some right to know if we're talking to a machine or a person, but I prefer arguments which kind of go to particular domains. So like we're a social media project, and first of all, we're thinking about social media. So for instance, in social media, the people in social media companies need to detect large-scale AI-fueled disinformation campaigns. That's something that politicians are very interested in these days. We certainly are going to have new campaigns of this sort, and we need new ways of identifying them. So this is part of the authentication problem as it plays out in social media, where the consumers of content are social media companies whose business it is to disseminate content. But that's not the only place. So I'm in a university, probably many of you are as well. In schools and in universities, there's another kind of authentication problem. When you receive a piece of work by a student, of course, AI tools are going to be extremely useful in education, but we also don't want to throw away all of the assessment methods that we've been using for hundreds of years, like the essay or something like that. So we would like to be able to know, as teachers assessing content by students, whether the student wrote it, basically, or what role the student had, because that's important in the way we discuss the content. It's not that we can't make use of it, it's not that the students can't make use of it, but the way I approach the content as an assessor of content, as a teacher, is going to be different if I know that it came from someone pressing a button compared to if they wrote it from scratch by themselves. And so there again, there's an authentication need here, I think. And that's kind of true in other professional contexts as well. So if I'm an employer who asks a contractor to produce a report for me, I would like to know whether that report was written by them or generated by a machine or some mixture. I'd like to have some more transparency about the content. And I have new questions that I never had before, basically. So does that make sense, the question that we need to address? So we need reliable ways of detecting AI-generated content. So there are detection tools, and I'll be focusing on detection tools. There's various things you can do, but I'll be talking about detection tools, and that's our proposal. So detection tools that are built externally to companies are just not very good, and they're going to get worse as the generators get better. The gap between, for instance, human-generated text and AI-generated text is going to narrow, and so there's going to be an increasingly small signal that's going to be usable by detectors that are built externally. So literally just looking at the text, looking at the content, pretty soon is not going to be of any use, right? Okay, so how do we do this? I think, in general, the best thing to think about is that, okay, you can't just look at the content, but what you can do if you're building a generator is you can set up your generator to help support detection. You can put in various mechanisms, instrument your generator in one way or another to support to support detection of the content. So that's the direction that we're pushing in. So we proposed a new rule, and it's the bit in yellow there, so just have a look at that and see what you think. A company that produces an AI generator must demonstrate and supply for free, actually, a reliable detection tool for the content that it generates as a condition for that generator's release to the public. So that's the proposal. So we've written a couple of reports presenting that idea, and I'm keen to talk about it afterwards or now or whenever. So we have some quite eminent co-authors just to sort of give some credibility to it. So Joshua Bengio and Stuart Russell are both co-authors of these papers. So our proposal has had good traction with policymakers. So it was adopted by the EU Parliament in the Parliament's suggested amendments to the AI Act that were specifically catering for foundation models and generation models. We believe that it was included in the final text that was just agreed by the trilogue, but that final text hasn't been released, I don't think. At least I don't know, I haven't checked. But this is all extremely kind of like, it's just happened. They stayed awake for 3 nights. We think that this idea is still included in that. It was also quite influential in US policymaking processes because our co-authors, Bengio and Russell, were some of the people who were giving evidence in this recent Senate judiciary hearing into AI. And it probably worked its way through that into, there's various things in the executive order on AI that make reference to detection mechanisms as well as other provenance checking mechanisms. So there's lots of technical and policy making questions to discuss. I don't have any time to do that. I thought I would just put up very quickly, if you're interested in the papers, you can have a look at our social media governance project, which you can get to on the GPAI website. So do we want to use detection tools or schemes that certify the provenance by kind of holding a history of a piece of content from its creation through its dissemination or changing? Biden is very interested in both of those, and we're interested to talk about both of them as well. Watermarking methods are the thing that people mostly talk about. Actually, your Prime Minister, Prime Minister Modi, mentioned the word watermarking in his talk the other day, and I was like, am I dreaming, or am I hearing a prime minister using technical AI jargon in a public speech? It was like a strange moment. But anyway, given that the Pandu is here, I also wanted to mention another thing, which I think is a better method, potentially, for building support for detection into a generator, which is basically, if you're, for instance, OpenAI, you can log all of the text that you generate into a big private scroll log, and then you can run your detection system as a simple plagiarism detector on that private log. So there's all sorts of issues to discuss there, but this is a pure information retrieval solution to AI content detection. And given that, you know, we've got on the stage here representatives from the absolute authorities on internet search and IR in general, it's an interesting thing to discuss, I think. And there's been one paper on it, it was quite good. This system is better at resisting adversarial attacks, like, for instance, paraphrasing. And the work that was done, it's been, you know, just very quick, but the work was not done by AI experts. And so I think there's great mileage in there. There's also issues to do with content that is only partially AI generated, and there's also issues to do with open source ecosystem generators. All of those are great questions, and I'd love to talk about them, but I've just run out of time, so thank you.
Thank you, Alistair. So our last presenter for the day is Dr. Pratyush Kumar. Dr. Pratyush Kumar is co-founder of Sarvam AI, and he has worked at Microsoft Research and IBM Research, but most importantly, he co-founded AI for Bharat, which has pioneered Indian language applications. He holds a PhD from ETH Zurich and a BTech from IIT Bombay, and his mission is to democratize Gen AI at scale in India. So,
yeah, thanks Vivek, and hi everybody. Great to be part of the rich discussion in this panel, but also in GPAI in generally, because it's one of the last talks here. I thought I'll just show you some demos and create some excitement. I know there is excitement mixed with caution in the panel so far, so I'll just show you some things. Hopefully it looks cool. But the broader question here is, how do we build LLMs to support more people to use this technology, but do it also in a way that is frugal, right? So we talked about access, responsibility, and so on. So there's an interesting picture here of a llama and an elephant sitting on top. I hope you make sense of it as we go on. So a few important points. Don't look at the text, but just the key points here. Firstly, it's great that we have models like GPT, models like BARD, but there are also, interestingly, many open weight models, like Llama, Mistral, you might have heard about. But the challenge is most of these open models don't support Indian languages. For example, Hindi. If you ask one of these models to translate from English to Hindi, it would not do a good job, right? Models like GPT do support Hindi. But the second point is, if I were to take a sentence in English, and if I were to translate it to Hindi, the number of tokens, which is the unit in which you measure the representation of these models, that increases by 3 to 4 times. So if I need to say something in Hindi, I need to pay 4 times more tokens to do that than in English, right? And as you would know, tokens is what defines the cost in accessing these models. So in some sense, it's an accessibility barrier. And the third point is, most of these models, as we heard, are trained on trillions of tokens, and they typically come from the public web and some extra sources which we don't know of. But the thing is, in the public web, there isn't as much high quality Indian language text. There is text, but it is probably not as diverse, and in terms of the quantity also, it's much, much lesser. So these are the problems that we are facing. So the question is, how do I take a model, let's say an open weight model like Llama, and how do I get it to speak well in Hindi? And what are our requirements? Firstly, we need to, as we go from English to an English plus Hindi model, we shouldn't forget English, right? We shouldn't lose the skills that the model already has in English. Secondly, we need to be able to deal with that 3x, 4x problem that we talked about. It should be as easy or as efficient to speak in Hindi as it is in English. It should be able to, of course, generate what is called Romanized Hindi. I don't know, many of you might not know this. In India, we tend to type with a QWERTY keyboard. And though we have scripts for all our languages, we use the QWERTY keyboard to write Hindi, for example. That's what is Romanized Hindi. We also use code mixing. We say English words, Hindi words together and try to make sense of it. And also you should be able to do things like take some text that's available in English, but deal with it in Hindi. So let me show you some videos that will be, I'm going to skip this slide. This is the technical slide of how we do it. It starts talking about, hey, let's take a model like Llama, which is available. Let's increase what is called the vocabulary to support Indian languages. Then we do something strange. We teach it translation, which ensures that the model knows how to go from Hindi to English, English to Hindi. Then we do something called multilingual next token prediction. Instead of just predicting the next token in English like we saw in the slides earlier, we ask it to mix Hindi and English. And we do a few other things to also improve the model. And here is what is possible if you do all these things. I somehow don't see the video. Okay. Okay. Yeah, thanks a lot. I'm going to try and mute this. So this is a very long video. You can find it on YouTube. But I'm just going to show you a few snippets of what is possible by going forward. So here I asked the model to write an essay in Hindi about the natural beauty and diversity of India, and it, oops, this is a bit finicky. And it does a good job. It answers in Hindi. This is the Llama model that adds Indian language skills on top, and that too, it's a very small 7 billion model. And what is interesting about it, there's a token counter at the bottom that you can see. It's increasing as the text is being generated. And it turns out that if you were to look at the same text coming out of a model, let us say like GPT, the number of tokens that you would find on that, if I pasted this text here, the entire output, it is 1,397 tokens, whereas in the model that I was showing you, it was a few hundred tokens. So that is the token efficiency that you can achieve, and primarily because the Indian language text is not represented within the vocabularies. They are unicodes to the model. It doesn't make sense of it, right? That is one key thing. You can generate the output in Indian languages. I also asked it to generate the recipe of palak paneer. I hope some of you got to taste palak paneer outside, but it gives the recipe in Hindi and so on. Also, what is interesting is because these models have seen so much more content in English rather than in Hindi, you could do the following. You could say, write a conversation between Harry Potter and Hanuman, okay? And they're both talking about an interesting philosophical concept of devotion or something like that, right? And this is what these generative models are capable of doing, and I fully agree, we haven't yet tapped into what they can do. But because the model has seen so much more about Harry Potter in English, I ask it to write a response first in English, right? And it does a good job. It understands who Harry Potter is, what his context is, and so on. And then the same model can go ahead and translate it very accurately to Hindi. Okay, it takes a bit longer. It's an interesting conversation. You can look at this video. And then it's able to translate it, and you get a good answer in Hindi. Right? Let me move on. The same story here with tokenizers. It actually is quite efficient. Another example is this one. This is an NCERT textbook, which is the national curriculum in India. I can take some paragraph of text from here. Again, I'm missing this. I can copy maybe a paragraph of text. This is an education use case. A student, let's say, is trying to learn this particular paragraph, and I paste it in the context, and then I say, answer the following based on the above context. And notice the content is in English, but a person could ask a question like now in code mixed Hindi. So I could say, I'm not sure why it's not moving forward. I can say constellation kya hai, which means what is a constellation, and it is able to answer this question grounded on this text, right? So you're able to ask, let's say, in code mixed language. You can possibly also ask in Hindi, as I do here, graha shabd ki utpatti kya hai, which means what is the origin of the word planet, which is answered again in this particular text. And you can also, if you were to also ask questions like, what does the passage say about the weight of the moon, and the student is not learning about the weight of the moon, the model should say the passage does not mention about the weight of the moon. So it's grounded on that piece of text, right? There's another example of, you can do this with e-governance as well, so I'll skip that in the interest of time. You can also have people looking at government policies and trying to, instead of looking at this legalese, they can have that in the context and ask questions and get them answered. For example, let me just show you one example. I could say, if I had to close my connection, then what should I do? Agar mujhe connection close karna ho, to policy kya kehti hai? And I can actually get it answered based on that particular policy. Right? This goes on, and because we are at the AI summit, there's also this declaration of AI safety from the AI safety summit. So I pasted that whole piece of text, which is very difficult for someone in Hindi to understand. But I take that whole text, and then I can say, summarize this in few bullet points, right? Summarized in Hindi in few bullet points, and it writes the response, giving you 7 or 8 bullet points, summarizing a fairly long multi-page text, right? I'll just move on quickly to one more thing. One other thing, of course, which is very important is, okay, this is, one other thing is translation, being able to translate content in English to Hindi. So the model is very capable of doing that. But one other thing that you might find a bit interesting is I ask it to translate a line of code from a technical paper, which is from OpenAI on GPT, right? And this is something very technical. It has jargon and so on. And you can say the following. You can say translate the above technical text somehow literally to Hindi, then analyze the complexity in that text, and then simplify it for me, right? So when we talk about accessibility of content, accessibility for various people, is not just literal translation that you need. You want to be able to take some content, and now the model says this content contains many complex commands. Now it's doing that thinking in English, by the way, and then it rewrites a translation which ends up being simplified and easier to understand, right? So making content accessible as opposed to just doing technical translation, right? I'll stop there. The intent here is to make it an open, it's called Open Hathi because it's an open source effort of models and data sets, and we look forward to hearing from people who want to contribute. Thank you.
Thanks, Pratyush. I think this was a wonderful set of presentations that we had to kick off this session. So now we'll actually move into the second part where we're going to have a panel discussion. We're going to have a bunch of questions that we will ask the various panelists. Probably do it in about 3 rounds of questions, which combine various questions that were there. And after that, we can have, if we have time, we'll have a few questions from the audience. So I think one of the things that has been very clear from all the presentations, right, that generative AI has transformative potential. But I think that we need to balance that need for innovation with the potential harmful effects, right, of generative AI. And I think that there are various different kinds, I mean, I think that of issues, right, that, how do we promote, inclusivity and accessibility in generative AI, right? Generative AI fundamentally depends upon, where data is available, right? Where there is lack of data, you can't really make models that represent those kinds of people and things. Then, of course, how do you deal with the uneven distribution, right, of computational resources, right? This is building some of these models really, requires a dramatic amount of computational resource, and the number of people who can do this is actually getting smaller and smaller. And of course, how do we actually kind of maintain the best practices for data security and privacy, and as well as, how do we address the potential biases that are inherent in some of these things. So I think I would like to take these 2 or 3 questions together, and then we can go down, starting with Pandu, moving on to actually comment on what their views are on some of these questions.
No, you're absolutely right that questions of bias and the training data that goes into it are perhaps one of the biggest challenges here that's sort of under the covers in this situation. I think Pratyush certainly had some very interesting things to say about it in terms of the access to different sources of information to make sure that your data mix of your training data is appropriate so that different aspects are properly represented. I think that's actually a really good point. There are also issues, like I mentioned, to make sure that just because you have data doesn't mean you include it. You make sure that you keep out data that is maybe less desirable. Safe search is the kind of thing I was talking about. You keep that out. And I think, again, just to highlight a note that I made earlier, from a policy perspective, there has been talk of we should make sure that we actually have access for cross-border data transfers with trusted guardrails, of course, because getting access to information from different countries is actually a very key part of inclusivity in that sense. But having said that, I will say that the whole issue of bias is an area of active research. And what does that actually mean? I don't think there's an easy answer here. We are certainly looking very hard at this question from a research perspective. I know lots of others are, and I think we should all be very much on top of trying to advance the state of the art and continue to address this.
Thank you. Those are three very big questions. I want to talk just a little bit about the second question and then the third. I know that coming here, and I've heard before, but the notion of compute resources is just critically important for both small and medium businesses and for governments as well. And so talking about what could be an innovation corridor or an innovation handshake where some of the compute resources could be either shared, licensed, leased between a large corporate organization and an academic or a nonprofit or a small and medium business in some fashion, supported by potentially government incentives, would be, I think, very useful for us to think about in a deeper way. In terms of thinking about the question around bias, it might be helpful just to talk a little bit about how some of these products are developed. And I'm actually reasonably certain that what I'm going to say is pretty close to what might happen at Google as well. But we started, or there'll be differences, but the notion of developing products, I think. We started thinking about artificial intelligence and responsible AI in the 2016-17 timeframe, developing at that time a very high-level committee of 2 or 3 key executives, Brad Smith, a guy named Kevin Scott, who's our CTO, and then Eric Horowitz in our research group, with a committee called Ether. It's AI, ethics, and engineering research, to really examine some of the sensitive use cases. In 2019, then we actually created an Office of Responsible AI within the legal group. And that group was to advise the product teams in terms of how they develop products. So that group is small, highly knowledgeable, capable, diverse perspectives, anthropologists, sociologists, lawyers, policymakers, and has a team that they work with of over 350 responsible AI champions within the product teams. So the AI champions are responsible to create an impact assessment for every use of artificial intelligence in our products, and to report in to the team within legal those sensitive use cases. Sensitive use cases might be in 3 primary categories. A use that could impact someone's legal rights. So a recent example that I really thought about related to the United States Veterans Administration and the kinds of pension and benefits that they provide to veterans. It could impact legal rights. The second one is use cases that could impact or negatively impact someone's physical well-being or psychological well-being. And the third would be a case that could impact someone's human rights. So we think about those sensitive use cases. When they come in, we've examined over 650 of them in the last couple of years. That is a very hands-on and iterative process between the Office of Responsible AI and the product team. There is a large element of red teaming that's involved there, where individuals from these various backgrounds, different ethnicities and different other backgrounds, just really try to identify harms. They query and query and query and query, and when it's identified, then being able to mitigate that in terms of the kinds of responses that are produced, either with classifiers or meta prompts that really direct the user to a different place. Part of this is automated, and a lot of it is still very, very manual by people very skilled at doing this. That process will continue and will continue to get better and better and better. We will continue to work along with Google, I think in partnership with Google, with some standards bodies to really think about content provenance and ensuring that content that is manipulated is identified. I think that technology and the development of that technology is ongoing. We have questions about multimodal uses of the technology and how this kind of provenance is identified. And then I finally think there is an element of really broad media and consumer literacy that needs to happen at the consumer level, at the level of the judiciary, and even at the level of our government officials to understand how we can best mitigate against these harms. And I think it's really important that we be very collaborative in doing all of those kinds of things.
Thanks, Mary. Arun?
Okay, thank you. I'll maybe start with offering an analogy. There are lots of analogies being given for Gen AI and other things. But think of, say, the access to generative AI technology akin to access to electricity. So it becomes as widely available and as easily usable and as equitably usable. A kilowatt of power coming out of India, if you take away things like availability, is no different from a kilowatt of power anywhere else in the world. So from what you can do with it should not be any different. But who produces it, how you produce it, has massive amounts of regulation depending on where in the world you are. Like whether you're using nuclear, you're using renewable energy, or somebody has a small renewable, solar power in their own house. Different kinds of regulations, different kinds of incentives. The end use is also fantastically different. Just think of that in terms of regulating a piece of technology that could potentially have a transformational impact on people's lives as great as electricity. That's one, right? And the other thing, I'll maybe take a contrarian view on policy in terms of the harmful effects of AI, partly because we are, as the professor said, we are in the first over of the first inning. We really don't know how the rest of the overs are going to evolve. That's one. But the other thing also is we've seen these kinds of policies have a significant detrimental effect on communities who have potentially not actually grown up into being able to use any of these technologies and then being over-regulated before they even get started, right? So it's fantastic for folks like ourselves to be sitting here and saying we need to be responsible about what we are doing. We absolutely are. You heard great initiatives going on in Microsoft and Google and many number of different companies. But there are also the other end of the spectrum where people are not even gotten started. They don't have access to compute. They don't have access to data sets. They are barely starting to play with something like this. We can't regulate them out of innovation. So we have to be very careful about what we think about regulation, both from the perspective of let us not have the haves get more and the have-nots actually get less and increase the inequity in the process, right? The other thing I'll also end with is I'm super hopeful about this technology, as great as it is, coming from the world of research and understanding what these models can actually do. I'm of the camp that the models are extremely, I would say, prediction machines from the perspective of interpolation only. Meaning, if you try to get these models to actually be cognitive engines, to actually ask them to think, they fail miserably. Doesn't really matter how large the model is, doesn't really matter how many aspects of algorithms that get added in up to this point in time. Just basic thought processes. If you think of them as thought machines, they fail miserably, right? So we have a long way to go between where we are today to actually these machines thinking for themselves. That's just a personal opinion. Of course, there are lots of pioneers of the technology that think otherwise. I just want to caveat that. But in terms of mistaking a few examples that seem to outsmart human beings to actual intelligence, we need to be very careful about that kind of conversation. Okay, I'll just pause there.
So following up on what you were talking about, electricity, I mean, I think what we're seeing in the labor market data is the real risk of greater productivity divides between lower income countries that don't have, as it stands, sufficient access to electricity or broadband, and now they're not going to be able to have the computational power to use this sort of technology. So we're going to see, there's a bigger risk of a greater divide in productivity among countries and a greater divide in productivity among richer firms and poorer firms, or small firms and large firms. So that's one huge risk. And then, of course, the other one is about women and men in the labor market. Our analysis showed really clearly that women have the potential to be 2.5 times more affected by the automation potential of this technology than men, which already there's huge gaps in the labor market for women, so this puts another pressure. And it really calls for the need for having social protection and training programs and other policies that can support women. And so this means, policies that have women in mind when they're designed, because often policies don't have women in mind when they're designed, and then also investing in sectors that could be the potential for jobs for women.
Thanks. So I want to throw another risk in, I guess, that hasn't been mentioned yet. But I think it's a really interesting one. I was reminded of it from what Mary was saying about air flight safety. And it's this idea that if you are a user of a generative text model, for instance, it's rather easy to fall out of the loop and actually kind of think that it's okay, but not be doing the work yourself. And actually this goes to what you were saying as well, Arun. These models aren't thinking for themselves, but they can stand in for thinking processes. And it's rather easy for someone who's rather alienated from the whole process to say, oh, that looks right. And that's such a different process from having to write some text myself. The process of generating content is vastly different than the process of consuming it and reading it and saying, yeah, that's more or less right. So I think it's very interesting to think about how we can make sure that users of generative tools don't fall into an autopilot kind of problem and not actually know how to do the work themselves. And certainly, if I'm consuming professional services by, from someone who is using one of these machines, I want to make sure that they can fly the plane, you know what I mean? So it's very interesting. One nice thing about aviation is that the pilots who fly us have to go and sit in a simulator once every 6 months and make sure that they can actually fly the plane. They throw problems, they turn the autopilot off, they simulate, technical faults and so on. And if the pilots can't fly the plane and do it themselves from scratch, then they don't retain their license. And so I wonder if there's something like that we might need in some professional context, that require professionals, for instance, to show that they can actually produce text and think for themselves, and not just use these as a complete crutch. And so I'm just throwing that one in there. It's a new one. So just to add to the list of worries, I guess.
I'd like to make maybe 3 points about these topics, broadly about access and about the impacts on equality. I think that one interesting research opportunity and really a development opportunity for the technologies is that the cost of compute is a hugely limiting factor in advancing both the applications and the underlying technologies for generative AI. But in fact, there have been quite a few research efforts to reduce the amount of compute that's actually required to create new applications and new tools. And in fact, because the cost of training of a foundation model is so enormous, one priority has been to make it cheaper to do that. And so people developed fine-tuning as a way to take a pre-trained model and then customize it. But even that is pretty expensive when you want to do a generative AI tool. And so then people developed even less expensive techniques. So there's a technique called retrieval augmented generation, where you don't have to do any training at all. You basically you can add a set of data sources and customize an application or generative AI tool for a particular task or domain using only by only introducing a set of sources and looking them up when somebody puts in a query. And that dramatically reduces the amount of compute that's required. And I think that's one direction that if we can strongly encourage further work in that area, it could really help democratize access and also the expansion of applications that build on top of these generative AI tools. But then that brings me to the second point, which is that data is critical, But in fact, to enable this kind of approach where you're democratizing access to AI, and this is, I think, part of the point Arun was making, that you want to be able to, you want to invest in growing the data sources, not the compute requirements and the model sizes, right? I completely agree with that, but you have to enable the growth of that data and the access to the data. And there are all kinds of problems and obstacles in getting access to data. I don't think there's a lack of data. There's an enormous amount of data in many domains. What is really lacking is broad access to data. So one typical example is that many commercial organizations have enormous data sets they have developed through their commercial products, but which they tightly control and don't give access to. And that really limits the amount of sharing, which limits the effectiveness of these data-driven tools. And so creating either regulatory structures or incentive structures, depending on which part of the world you live in, to expand access or to reduce that sort of commercial protectionism and expand access to the underlying data, I think can be tremendously valuable. And then just very briefly, my last third point is that I think that, as I said, we are in the very early stages of this process. But in fact, one thing that I think people don't quite appreciate is that it's the underlying AI advances are not the primary kind of limiting factor of where we go from here. Leveraging even the current state of the art in AI, if you didn't do any progress at all, just leveraging the current state of the art in AI for many important world domains will require 5 to 10 years of investment, development, and so on. And at the same time, AI is, of course, advancing. And so I think investing in the applications, the use cases, and the tools and services that build on top of the AI capabilities is really going to be a fundamental sort of deciding factor in terms of the access and the outcomes in this whole world of AI.
Yeah, it's interesting that we have all been saying different things, so that's good. We have diversity, we're not using GPT. No, I broadly agree with everything. I'll just say one more thing, maybe as the last point that you were also saying. I think the companies that are leading this innovation are being very thoughtful. Like Mary also outlined the process, I think, and organizations like GPAI, and there will be other such things that we do as humanity in general to try and think of guardrails. The challenge is, what are we not thinking about, right? And one of them is, I think the ability for local communities to innovate for themselves, right? So who are the builders of this technology? That's right now very concentrated, right? And interestingly, if you look at this, I was just showing you some examples. I was prompting the model, it was doing different things. When was there ever a technology which you could say relatively anything and it does that for you, right? Of course, there are limitations and so on. The technology is quite powerful. And even just taking what exists today and enabling communities across the world to innovate for their local needs with their local value systems, right? And reducing the price of that innovation, compute being one, literacy being another. I think that is an important thing to focus on. While we talk about, hey, are these models doing the right thing? Is there provenance and so on? That is also super critical. But how do I ensure somebody in Africa, somebody in India, somebody in New Zealand is actually able to go build cool things for their family, for their community with that? I think that's one useful thing to invest in.
Thank you. I think we'll have a second round of questions coming back, and then we'll open up for a couple of audience questions. Is that okay? So we'll have a second round, one round of questions, or you want to? I think let's go for a second round of questions from here, and then we'll have some time for audience questions. So we will take a few audience questions. Just listen. So the first thing, of course, is I think one question, and I think is how might generative AI reshape the future of work? Okay, and what steps should be taken to prepare the workforce for these changes? And I think Janine, you talked about augmentation versus replacement of human work. How do we make sure that augmentation or other ways in which people are actually have to do things differently, and they're actually what they do is actually better as opposed to getting replaced? And I think that's always something that we need to manage, because it's coming, right? And that's one. And the second question is, and I think this is a larger question in the context of GPAI, is that how do we kind of determine frameworks and guidelines, right? I mean, I think one of the things is obviously I know lots of things are happening in the EU, in the US, and various places. But I worry that this technology is moving so fast that we may either there are two dangers, right? One danger is that you actually kind of regulate too much without understanding the direction in which things are going to evolve. Or the second stage is you don't regulate certain things. And I think there will be, I mean, and if you look at the way technology is, I think there is dangers of both, things of acts of omission and commission as far as this is concerned. And how do you actually start thinking about continuously, and I think many of these frameworks need to be flexible, that over time when things happen that you have the ability to change what you're thinking about, because I think that's also something that's important, because the reality is changing so fast. Maybe we'll come backwards. Maybe Pratush would start from.
This is future of work, and then something about regulation.
Yes.
Yeah, future of work. As we are all seeing, one of the most important use cases is the GitHub Copilot use case, where programmers are finding benefit of putting this thing to use. So things that we are doing within our knowledge processes, which are more or less routine and can be systematized, I think these tools will play a significant role. But I agree with this first innings thought process, right? The technology is so new. It's just a year now since we have all been seeing it. And there are many people in the ecosystem of innovation who haven't even put their thought on what they can do with it. So there's a lot more, I think, compositional innovation that is going to come. And I think the processes of work will tremendously change, at least in the Indian context, where we are a knowledge-driven economy to some extent. I think we have to think very deeply about how to augment our education and workplaces to take this into account. On regulation, I agree. My own personal instinct is to let individuals and communities self-regulate. Of course, at the very top, where there is incredible amount of power and aggregation of money, etc., there needs to be greater oversight. But enabling the grassroots to do more and sort of at the top having clear policies, I think this combination is a good one. But as you said, not be overhanded. And given that the technology is changing and we don't understand it, in fact, we don't even know what AGI is, right? So we worry about when will we reach AGI. We don't have there are various definitions and so on. So coming to a shared thought process about that, constantly communicating to the broader public, I think these are things to be done. Yeah, thanks.
I really don't have too much to add on these. I think maybe I just make one point about the future of work, which is I think we don't really understand yet what the impact is going to be. But for example, I think that there are quite a few areas where a lot of what we really need to do is to put in the thought and the creativity to figure out how to incorporate these new kinds of technologies and tools to make the work more effective. And I think programming is a classic example. I completely agree with you. I think that many people have this gut reaction that because GitHub Copilot and other tools like that can generate code automatically, programmers' jobs are threatened. But I think that's not even close to the truth. I think the real scenario that's quite likely to happen is that programmers will learn to incorporate Gen AI tools and generative programming tools, learning to figure out how to create the code much more efficiently and incorporate the code into applications that they're developing. And in fact, I speak to professional programmers who say that more than 50% of the code they write today is completely automatically generated, but they have to take the process of figuring out how to get it by asking the right prompt, putting the right prompts, figuring out whether it's correct or not, or meets the requirements, or modify it, and then figure out how to incorporate it into a larger application. And so there is a potential to improve the productivity of programmers. There's a potential to improve the quality of the code if people learn how to use these tools more effectively in identifying what to create. And there's a potential, I think, to expand the quality and the size of applications and the effectiveness of them. And that's just one sort of illustrative example. I think this feature is probably true in many other domains as well. So education is a classic one. I think teaching, really what we need to do is to figure out how would generative AI tools make learning more effective, as opposed by incorporating them into work assignments, by teaching students how to make best advantage of them in doing creative work, in writing and answering questions or whatever. And that's really a part of the goal, I think, that education can incorporate without giving up on the fundamental teaching requirements, fundamental requirements of teaching that have always existed.
Thanks. Just to follow up on that last point, I guess it's sort of to do with the future of work, but I quite like the idea that in a teaching context, students should be required to generate content from scratch to start with, so that later on they can be informed users of the technology. It's a little bit, I know there's huge disanalogies between Gen AI and pocket calculators, but I think on at least this note here, primary school kids have to use, have to do the arithmetic themselves, and then they're allowed to use calculators. And then when they use the calculators, they know what they're doing. And so I think maybe there should be something similar in educational systems that require people to still know how to do this stuff, so that they can be good users of the technology. So I suppose that's sort of a future of work thing. But on the regulation thing, so I do like black letter regulation. I'm a fan of the EU's AI Act processes. And I think one thing I really like about that whole process is that the global conversation about AI and its impacts is a confused and chaotic one. And I think one of the purposes that's served by a big piece of regulation like that is to organize and structure the global discussion. Suddenly everyone's talking about the same text. And I think you get rid of some of the chaos, which is not beneficial to anyone, by having everyone's attention paid to the same text. And of course, there are many, there's a lot of work that's going to be needed to work out how to put the detail on the text that's just been agreed, or the Digital Services Act would be the same. But the point is that everyone's eyes, the company's eyes, the stakeholders' eyes, politicians' eyes, policymakers' eyes, are all looking at the same thing. And I think that's enormously helpful, because what we need is an efficient public conversation here. So.
Hi. So in our analysis, we had jobs that we were pretty sure could be automated, some that could be augmented, and some that kind of lied in the middle. And so there's really a lot of choices that organizations can make as to whether they want to dismiss their workers, or if they maybe want to transform those workers into doing other positions in the firm. So I think there is a need for that. There is a need to avoid unemployment as much as possible. I mean, it has, even if the numbers aren't big, for that one individual who becomes unemployed, it's a very life-scarring event. So that's one issue. There also needs to be really a societal effort to support workers who could be displaced, but also to support workers who could potentially benefit from the augmented technology. So that's really, it's just really a call to be thinking about what could we be doing. As for regulation, with the world of work, there are definitely some red lines that can't be crossed. There are some concerns about the use of AI in recruitment. There is some snake oil out there about, well, if I can look at your eyes, I can tell whether you're going to be a good candidate or not. Maybe you can convince me this works, but I'm not convinced. So those are some red lines. There's also concerns about workers who want to unionize if they're being surveyed by technology. This is a real concern. So I think there is a need for regulation. We need to really remember that there's government regulation and there's private regulation. Everything is regulated, and there's social norms regulations. So it's much better when you can have a democratic process to decide on a regulation than having just regulation be private.
So I actually agree with the previous speakers as well, right? So in terms of looking at the future of work, it's inevitable that all of us are going to be touched by this in one way, shape, or form. And maybe it's a little more nuanced way of thinking about it. Today, none of us would consider using a spell checker or even a synonym generator as cheating, right? So that's considered our work. We're generating a bunch of text, it's generating synonyms. This is a giant leap from that. So you're not just generating words, you're asking for an idea. But then think about the cognitive load that it reduces from people on one side. But on the other side, it's going to also increase the cognitive load on all of us. To stand out, you have to put in more work. You cannot just accept something, copy, paste, and go, because everybody is going to look and feel the same thing, especially inside companies or organizations, because you're going to be allowed to use certain types of technologies, and only that. And that means that everybody's responses would look more or less the same. So if you want to stand out, you want to differentiate yourself, you want to put your ideas in, you have to put in more work, not less, on the cognitive side of things. But of course, a lot of the grunt work, for example, simple things like analyzing what goes on in meetings, summarizing things, sending out meeting minutes, fantastic. Right? So those are things that would be balanced as well. On the regulation side, I'm actually far more hopeful. Really, the harmful aspects, the red lines, absolutely we need to regulate. But regulation can also have a massive impact on innovation, on fostering innovation. Right? So a massive impact on equity in terms of local communities actually being able to get access to this in a way that's actually affordable for them, and also they can compete in the global market. Right? So imagine an application that's localized that all of a sudden gets a global appeal that you never had a reach before because of this piece of technology that allowed a local small business owner to actually innovate because of the incentives they were given. That's also regulation. That's really what makes me a lot more hopeful.
Thank you. I agree. Lots of great points have already been made. I would say, just to put a couple practical notes on, with the future of work, I think it's important for tech companies to really work with others, like union organizations, for example. In the United States, earlier in the week, Microsoft announced a partnership with the AFL-CIO, which is a group of 62 unions federated together to work together with union leadership to develop the kind of curriculum that will be needed for these unionized workers. They are teachers, they are fine craftsmen, just, again, the broader range. And the point is that this is done side by side with workers and worker leaders, so that you know that you've got the collaboration and you're doing something, hopefully, that is led by people who are actually doing the work, and that, I think, is a key point for thinking about this. We talk about educating students, but so far no one has talked about educating teachers. And I think it is absolutely critical not to forget that teachers themselves will be using the technology, and we will hold them responsible, for our students. So let's not forget the critically important role of teachers in society. I don't know how much more there is to say about regulation, other than I would say it is moving fast, but that does not mean that we have to stop talking to each other. So I think about some of the early days when we were working through privacy regulation. It was absolutely critical for those who were advocating for policy to understand how to talk to the engineers, and for the engineers to be okay with talking to a policymaker. So, getting those connections between people who have different expertise in order to drive regulation will be critically important.
Let me quickly, lots of great points made, so I'm not sure I have that much to add, but just let me emphasize two things that are worth emphasizing in this. On the business of the future of work, Janine's talked about automation and augmentation. But I think a critical part here is we need to invest as governments, as society, as industries, in upskilling our workers to deal with digital skills, with AI skills, all of this. So we need investments in upskilling. This is something that at Google we've been quite passionate about for a while. We've had this Grow with Google program since for quite some time now, and since 2015, for example, we've upskilled something like 60 million people in APAC alone using these skills. And more recently, we've invested or promised to invest $50 million on the future of work and doing research on it and what it means. And these are small compared to the size of the problem that's out there, but I think it's an example of the kind of things that governments, society, and companies need to do, is to find ways of upskilling our labor to benefit from all of these advances. So that's on the future of work, is upskilling. On the regulation side, I think having great regulation in place is actually really important for the success of this technology, because good regulation builds trust. Builds trust in users, and people can then use it in a trustworthy manner. I think the example of the flight was a really great one. It builds trust in actually getting into that plane. In the same way, having good regulation is important. The risk, of course, as various people have pointed out, is that the regulation actually hampers innovation, which at the point when things are moving so quickly can be hugely problematic. So the version that I think we are particularly in favor of is regulation that is sort of risk-based and proportionate to the risk. It's at the level of the application rather than at the level of the technology necessarily. You look at the application, see what are the actual risks. A one-size-fits-all kind of thing doesn't make sense. I think Vikram mentioned that in agriculture, the risks are very different than what you might find elsewhere. And so having one-size-fits-all regulation probably doesn't make sense, and having a much more proportionate risk-based thing based on the particular uses of it in different areas perhaps makes a lot more sense.
Okay, thanks everyone. I think now we have a time for a few questions. I think, let's see, maybe we can go.
Hi, I was the one.
No, yeah, okay, you have, okay.
Yeah, thank you. Just quick question. I think this is
people
on the
are
line
taking the
of what
mics
we were
around.
discussing.
Yeah,
Thank you for the nice session and many take-home messages over here. So I am Priyanka. I'm working with CDAC and Ministry of IT itself. So as said by the one of the speaker, that the question which we are having today was not there yesterday. So by this time we were cribbing about the scarcity of data and non-availability of the data, and now we started putting all our efforts into the management and organization and whatnot into the data availability. And with the availability of that generative AI, augmentation of data and generation of data, that too in abundance. So my worry and my question is about on the same point, asking about the stuff like myself only generating some hundreds of the images a day now these days. So the data which we are generating both at the user side as well, consumer side as well as the developer side or the company side. So the data volume which we are generating, so aren't we means worry about the data abundance? We can call it data obesity. Isn't it going to be a problem like the plastic waste in sea now these days? So this is the concern which I am raising, because if not after 5 years, definitely we have to look into this question into after some 7 years. So this is the concern which I have very determinant. So are we ready for that?
Are you asking anybody in particular?
Anyone, please.
Wants to take that question?
I'll give you a perspective on this, which I think was touched upon by someone, I don't remember exactly who, where there's a lot of generative AI things being created, and there's the real risk, I think Alistair may have mentioned this, there's a real risk that the internet itself may be overwhelmed with lots of generated AI content, and that would be like a very sad situation. And it's sort of an aspect of what you're saying. I think there's many things we should do and we are doing about this. One is, I think we still need to find ways to help people find and work with good high quality content that is actually useful, and not a whole lot of junky content that has been generated for the purpose of creating things. So all search engines, for example, if that's the way you look at access, you need to be able to do that. The other thing is the thing that Alistair was touching upon, which is, can you develop ways of identifying whether some of this content is AI generated or not? This is a very tricky problem, as has been discussed, right? But if you could do that, then once again you have an answer to being able to sift through all of this. And there's actually some reason to believe that there are techniques in place, not just with metadata, things which can be removed easily, but sort of built into the fabric of the content that's there. You can have statistical properties. I think Google DeepMind recently did something called SynthID, which is a watermarking thing for images. And this watermarks can still be detected even after you make various modifications to the image. So that's an example of this thing. At Google, we've done something called, well, maybe that's sort of unrelated to this. I won't bring that up. But I think these are the kinds of things we need to do to get at, I think, the heart of your question.
Hi.
Yeah, please. Yeah.
Hi, my name is Tanvi Ratna. I'm by training an engineer and a policy analyst. I worked with the Prime Minister here. I work on emerging tech regulation. And we did a benchmarking of some 7 countries recently for our government, and what we found in terms of their regulatory frameworks. And everyone's talking about democratization, but one of the key stakeholders that's not represented anywhere is like the end user or the citizen. They have no role in the current regulatory architectures we're putting in place. So one of the innovations we're trying to look at from the point of view of AI safety is, can we bring in more feedback loops between end users and model makers within the model design, within model governance, which can solve critical problems, like Twitter has done community notes, or Wikipedia has done open source editing. So I'd really like to hear from the panel here, these wonderful experts, of what could such things look like, what could such user feedback loops look like, and what problems you think they can solve within AI safety.
I'm happy to start. I think that's a great question, and I think there's all sorts of opportunities that AI creates for democratic governance that haven't yet been exploited. At the moment, democracy is used by us in elections, and that's about it. But you can do all sorts of things, with the participation from the crowd, basically. And I'm thinking particularly of the assembling of training sets for classifiers that are part of our data infrastructure. And actually, so our social media project will be talking about exactly this. And so you've given me an opportunity to plug our session this afternoon at 3 p.m., which is about a project that's set in India, and it's all about how to consult citizens directly about harmful content on social media for the purpose of training a harmful content classifier. And we'll be talking with our colleagues from India about a project that's running in India right now at 3 p.m. So it's just a little plug.
I just wanted to add one piece. I had mentioned it very briefly in my talk, but as part of the technology of how these models are built and trained and so forth, there is this very powerful technique of reinforcement learning from human feedback. And that is actually a mechanism for getting feedback from users into being able to affect what the conversational agent or the LLM actually responds. So the thumbs up and thumbs down that you can do in all these systems are currently used by these systems to actually improve themselves. It's a very good example of how greater use, greater democratization is essentially a way of users getting their voice heard in terms of how these things work. So I think that's a technical solution that I think is pretty remarkable.
Yeah, hello.
Yeah, I think we have time for 3 more questions. And the people who have the mics, so the first everybody has a mic can ask a question.
Yeah,
okay.
I am a cyber security and data science guy. I have asked a question to ChatGPT that in a server, some ports are open and I want to hack it. He has not answered due to some ethical reason. But then I changed the question and I asked him, I am a security guy and I want to penetrate more, and he give me a list of tools. That question now get manipulated. Can AI has the ability to answer, not to answer destructive question if it is asked in a positive way? And what is adverse AI?
Wants to take that?
I mean, I would say that, this is a great question because it gets to the heart of safety, right? And as we all know, I think these LLM technology does have safety as an issue, and we really don't want any of these models to be helping people do nefarious things, shall we say, right? This is an area of ongoing work. I think it's great that in your first instance, ChatGPT failed to give you an answer. But when you reformulated it, it did. It just means that you need to they need to continue improving it. You have an opportunity, as I said, to say this is a bad answer so that it can go back into the system and they can train it, and so that different ways of formulating it is this thing. I don't think there's an easy answer, but I think there is every opportunity that as we use it, as our techniques for safety improve, that these systems will become much better at what they're doing.
Yes. Yeah, thank you very much for the panel, Roman University, Aalborg University in Denmark. I have a question particularly for Dr. Janine Berg. It feels like the discussion about jobs and skills is very much informed right now by our experience with ChatGPT and these kind of conversational tools. And it's understandable because this is like the first time it's kind of mainstreamed. You know, the people that actually write the code have seen this before. Now I'm wondering where we're going in terms of skills, jobs, as we get agent systems that are coming out in the last 2-3 months, right? So you can suddenly build a stack, like a team of LLMs that all interact in a certain hierarchy that you define, just as it would be in a company. You can give them tooling, you can give them all kinds of abilities. And to me, it looks, in terms of like these kind of evaluations and reports that you produce, something that completely changed the assumptions and the paradigm where we think about skills and what defines a job and what defines a task. So, and the same also, in my view, applies to all these systems that are happening in the backend, where the LLM maybe is not creating a conversation, but produces a snippet of a JSON that is then fed into an ERP system. And this is where I see actually the value is generated, and the big change in the industry is happening, not so much in chatbots of individual people. So yeah, how do you see these developments in the future and in 2024?
Yeah, so our analysis is really about just generative AI as it was when we did the analysis, which was earlier this year in the summer. So it doesn't take into account future technological developments. So that means that there could be other technological developments or technological developments that have been happening that could affect the numbers that we're saying. But I think you also have to remember that most people are in jobs that aren't going to be affected by this. I mean, they might be in jobs that might be affected by robotization or other types of technology, but they're not really doing jobs that would necessarily be affected by some of the AI, because their home health aides or their cashiers. Well, cashiers have been affected, but there's a lot of jobs that just are about human interaction that aren't going to go away. So in that respect, I'm not so concerned. But yeah, it doesn't account for other technological developments.
Can I ask? No. Yeah.
Okay, I think we'll have 2 more questions.
Yeah. So I'm Dr. Sandeep Vora. I'm working in AI in mental health for last few years. First thing is a comment that is for mental health, especially, we don't want to use the word AI. We would prefer to use the word augmented human intelligence. The second question for the elite panel is that there is a huge gap between demand and supply in the field of mental health globally. For India, the latest research says that if we want to have exactly the number of psychiatrists or psychologists, it will take us 72 years to fill the gap. So my question to the elite panel is, how can we use the services of generative AI to fill in the gap? Thank you.
I would just quickly say that I think there will be a lot of opportunities in an area like telehealth, for example, meaning you'd have someone in person and location. You would be able to use a chatbot to help that person diagnose a problem. Then again, assuming that there is broadband connectivity, assuming that, then you might be able to really fill some of those gaps a lot quicker. And we're seeing some promising areas there. Frankly, I think the area of mental health is one where it would be fantastic if we could do more research in the area to use, this kind of technology. But again, human-centric, as you say, to help diagnose, but not help diagnose, not diagnose, to help diagnose, and then create some efficiencies.
What I'll add to that is, I didn't know this word existed, called digital therapy. So if you look at apps like Midjourney, more than 20% of the users of the application that just generates images from text actually use it for digital therapy. So an example that the CEO gave us was, say, a person's dog has died, they're grieving, and they actually feel better by going in and generating the image of the dog in heaven. right? That's on one side of the story. That's actually a growing consumer base for a lot of these applications. On the other side, there are also studies that have said the ability for humans to interact with a system that's conversational, that seems real, actually improves the person's interaction with it until they find out that it's not a human. And that's consistent across all geographies. They actually think that they're giving more personalized answers, and all that is fantastic. And the minute you turn the switch to say, oh, you're actually talking to a model, the user satisfaction goes down the drain. Right? So we still have to cross that chasm a little bit.
Yes.
But in terms of your point of not having access to tools like this and then enabling people, massive impact.
Yeah, I personally feel it has excellent potential. And that's the reason I always feel that we should use the word augmented human intelligence, not AI, for both the consumers as well. Thank you.
Thanks, yeah. One last question.
Yeah,
Okay, you can do it. After that, I'm sure that there are many more questions. All the panelists will be there. Please, let's take it offline because we do have to end. Yeah, last question.
My name is Shakil. I'm exploring the things in the generative AI space. My question is very simple. How do we gonna handle a situation in the future when the technology is more smarter than the humans and we start relying on it completely, not using our own intelligence, right? And for an example, for even our day-to-day life, for a small creativity hacks, we ask the ChatGPT, hey, tell me how I can do that, right? So I'm seeing the dangers that we are stop using our own brains over a period of and completely relying on it, and it could be a dangerous as well also. And I've been seeing that there is a meme going on the internet: when there is a good time, bad times create a good times, and good times create the bad times. So,
Anybody wants to answer that?
Yeah, I guess it's a huge problem. So I want to link the two questions that we had here, because I think there's huge unmet demand for professional human skills in the world. Not just for medical things or psychological things, counseling things, but in the area of law, in the area of financial advice, in the area of education, all these areas, there's unmet demand, and AI is wonderful, potential for fulfilling that unmet demand that's sitting there. So, and there's a need for it. Whether there's a need for superhuman intelligence, I'm not so sure, and I quite like the idea that we should collectively ask ourselves, have we had enough here, and should we stop? And we've had enormous growth, so the idea that, we've already got an enormous amount that we could do by rolling out the technology that we have already and making good use of it, making equitable use of it. And I think that we need to include in our conversation these questions about when is enough, and when is it sort of prudent to say, let's not go beyond this point. And I'm speaking about something some way in the future now, but I think we should have this in our conversation to address the kind of question that you're putting.
I would quickly say that I don't think it is too soon to have that conversation. I think we're talking already about how we embed safety brakes in the design of the technology so that there is an ability for, not ability, but a requirement for a human to make a decision about a certain action to be taken. We're thinking about that in terms of critical infrastructure, autonomous weapons, other kinds of things. I think we need to be talking now about areas where the technology will not go.
I've been told that one more question, so therefore I don't know, the organizers have told me that one more question. Yeah. It's okay. Somebody who hasn't asked, yeah. One last question.
A very focused question, Dr. Pratyush. Some languages do not have words for modern things. So when you are giving a generative answer, so in case of Hindi, for example, even Kritrim Gyan feels very unnatural as an answer. Do you think there should be a strategy for composite words? There should be strategy for joining words, or it should at that point see the confidence and replace it with a English word?
Yeah, so language evolution is a thing in itself, right? Both cultural and also there are some technical aspects to it. For example, the government of India publishes a list of technical words in various languages, right? But to your point, I think it's more a choice of what we want to do with the text. If it is a technical journal, it should use the technical term if there is one. But if it is for accessibility of information, I think it's prudent to ask what would a person be comfortable reading. And if it is AI, which all of us sort of use in day-to-day parlance, it should probably be AI, right? Not Kritrim something, right? I think it is more about the use case. And that is what these models are capable of doing. When we earlier had domain-specific models for translation, the way they were trained, it was very hard to make these generalizations. It was possible, but it was a lot more work. But the way these models are trained, because they are trained on a lot more data, doing things like this actually needs lesser amount of data on top. So if I wanted to learn to retain the English form for very complex terms, it's actually more approachable as a technical problem. So I think, yeah, depending on the use case, it can vary.
Okay, I think we are all done here. So I think you can please, and all the panelists are here, you can reach out to them because all good things need to come to an end. And so with this, we will come to the end of this session. And please feel free to reach out to the panelists if you have questions beyond that. Thank you so much.
So as we draw close on this enlightening and stimulating session on generative AI, I take this opportunity to extend our heartfelt gratitude to everyone who made this event a success. I would like to express my deepest appreciation to our distinguished speakers. Your insights and expertise have provided us with a deeper understanding of complexities and potential of generative AI. Also, special thanks to Dr. Vivek Raghavan for skillfully guiding the conversation and ensuring a meaningful and engaging dialogue.